So this is a decoder, and it's used to basically detect the value of a binary number, almost convert it into its decimal value. So it uses NOT gates and AND gates, and here it's a 3-bit binary number. So it'll take 0, 0, 0, 1, and that will code, or that will kind of convert into one of these possible outputs, and only one of them can have a high value at any time. So 0, 0, 1 is just 1, and so that'll come out here. As you can see, it's x prime, y prime, z, and so 0 comes through here, and it comes complemented, so the 1 goes in 1 there, 0 is complemented here, comes in 1, and then here it just goes straight in without being complemented. And so all binary, or all decimal numbers from 0 to 7 are represented through one of these AND gates, and the values in binary will create a high value output just through 1. So this is a multiplexer, and you can use this to take 2 4-bit binary numbers input, and you can choose only one to carry on through the circuit. And this is done with a switch, just 1-bit switch, and an enabler as well. So you take your 4-bit number, say 10, 1011 or whatever, and that's going into the AND, and that's the value to be passed. And enable will almost always be on, and you'll want a low value for enable to low pass. And for your switch, either 1 or 0 will pick A or B number to pass on into the output. And in this case, if we want to pass A, we would want a 1 here. And that'll all go into the ANDs, and they'll pass through. And so for 1, it would get a 1 from here, 1 from the switch, and 1 from enable. So it would pass a 1, because 1's ANDed together. And this one would have a 0, and so it wouldn't pass through the AND. Or 0, 1, 1 wouldn't pass a high value. It would just pass a 0, which is what we want. So this is a basic demultiplexer, and does almost the opposite of a multiplexer where it takes one value, and you can choose to send it along different paths throughout the circuit. In this case, in this circuit, we're using 4 paths. In order to have 4 paths, to choose between them, we need 2 input switches. So we can represent the 4 paths with 0, 0, 0, 1, 1, 0, and 1, 1. Ooh, that's supposed to be 1, 1. Close enough. In this case, we only have a 1-bit number. Say we're trying to send this 1 down Y0 here. Well, we would want to take 0, 0, because the zeros right here are falling along this path, and they're both being complemented for this particular output. So 0, 0 would send down Y0. On the other hand, if we want to choose Y3, it would be 1, 1, since it's going along this path here. And with this, you can really have more customization over where your data is being routed throughout your circuit. So this is a shifter, and this particular circuit is just a one bit shift, I guess you would call it. Shifts only 1 over, and it can only perform a logical left or a logical right shift. So how it works is basically taking a 4-bit binary number, such as A3, right here, and if you take this 0 value, it's going to 2 AND gates. One of these AND gates is for a left shift, and one of them is for a right shift. And the way you're going to choose between that is this 1-bit switch up here. So right now it's set to 0, which is left. And so 0, we're down through this one, and non-complemented, so it's going to disable almost all of the AND switches that are connected to that one, because that would be the right shift. Instead, it's going to go through here, get complemented to a 1, and so A3 is going to go through this AND gate, A3's value. And in that case, A3 is going to be the shifted out bit, kind of the carry out. So it's going to be not exactly used. But for these others, they are going to shift over all 1 bit, all going through that same AND gate, or the same side AND gate. And then for Q0, we don't have a bit to shift over, because we're not going to use the carry out since it's a logical operation. And so we have a ground here, and we'll immediately just fill in with 0.